Hello. In today's video of the Turbo Blast, we are going to have a discussion on something very specific, which is known as constrained motion. And what exactly is constrained motion and what we are going to discuss that in a short while. But if you talk about the JEE or you talk about the NEET, not so much as far as the MHT CET is concerned, but definitely NEET and JEE, you definitely have questions asked from constrained motion. Now, so our study, like I said, today is on constrained motion. All right, and first of all, what exactly is constrained motion? For example, you kick a football and on the ground, and the ball is free to roll on the grass, assuming that there is no frictional force. Let's make an assumption, or maybe there is a frictional force, not a big deal whatsoever. So you kick a football, all right, and that ball rolls on the grass. Case 1. Case 2, now what you do is you have tied a very narrow or very thin bungee type of rope, a huge rubber band, to the football, and you now kick the football. Now the football will again move on the grass. Now I think you would definitely agree with me that the motion of the football in the first case and the motion of the football in the second case is most definitely not the same. In the first case, the football was free to roll, free to move on the grass. In the second case, there were some kind of restrictive forces acting on the football. So that kind of motion, which is under the action of some kind of restrictive forces, are known as or is known as constrained motion. So what would the exact definition of constrained motion is? Constrained motion would be an example where a body moves along a pre-decided path. I repeat, a body moves along a pre-decided path. So when you're saying it is moving along a pre-decided path, you evidently know it is not free. For example, you go from school to home, and school to home there are 10 different ways to go. Let's make an assumption. So depending upon what your mode is on a given day, you would choose any one of those 10 given paths. Now, case 1. Case 2, your mom now is in the picture, and your mom makes a statement that you will have to come home from school. Your school gets over at 4 in the evening. You have to be home by 4:15 flat. That is it. So obviously you're now going to make a choice of a path which will take you less than or equal to 15 minutes. So you are now constrained to move along a given path. That means that path now is most definitely pre-decided. So what is a constrained motion? Constrained motion is an example of motion of a body which moves along a pre-decided path under the action of restrictive forces. So it moves along a pre-decided path under the action of restrictive forces. Now ये तो हो गया constrained motion के बारे में. Now before we go ahead, there is something that I'd like to very clearly mention. First of all, there would be a number of numericals that would be doing today. So this video is going to be a little, quick, a little fast. So you will have to at times maybe, re-see a certain numerical so that it gets ingrained in your mind. So I'm going to go a little fast with the video. Number 1. Number 2. When we talk about solving numericals from constrained motion, please see that there are two broad categories, two broad methods which can be used to solve these numericals. I am going to discuss both the methods with you. That means using a given method, I am going to solve a given set of numericals, and using the second method, I am going to solve almost the same set of numericals. And you will have to make a choice and see which fits your speed, your understanding. then make a choice. As far as I'm concerned, I always find the second method which I'm going to choose as something which even when I was a student, I used to use. So it is upon you. You can either use the first method or use the second method, and using that you've got to solve the numericals. But before we go ahead with the study of constrained motion, there is a small bit of trigonometric note and which will help you solve numericals, because I'm going to choose those angles only. And first of all, if you have a triangle like that and you have another triangle like that, if this angle is 37 degrees, that is 53 degrees, then this would be 3, that would be 4, that would be 5. If it is 53 degrees, then this would be 4, that would be 3, and this would be 5. So is it very clear from here that cos of 37 is 4 by 5, cos of 53 is 3 by 5, sine of 37 is 3 by 5, sine of 53 is 4 by 5. So ye please dhyan mein rakho, we are going to use this when we are solving the numericals. Now let us take one example of a constrained motion. Let us assume that this over here is a car which has broken down, all right, and it has to be towed by a rope by using a towing truck. Okay, now this is the truck and this is the car, and the truck is moving with a speed of, let us say, 30 kilometers per hour. Now we are going to make an assumption, you know, or a practical assumption, and that is this rope or this connector, this could be a chain, it could be a steel rope, it could be a nylon rope, we don't know. So we are expecting this rope over here to be inextensible and it remains unbroken. It is inextensible and it is unbroken. Now if it is extensible, then what is going to happen is the rope is going to extend. The velocity of the truck is 30 kilometers per hour. The velocity of the car need not be 30 kilometers per hour. So you're very clear about that. Likewise, if you have the car moving with 30 kilometers per hour and the connector or the string or the rope over here breaks, then obviously the car is not going to move with 30 kilometers per hour. So we are going to solve numericals where the connector or the rope or the string or whatever we are talking about will be inextensible and would remain unbroken. That means if you have the rope, if I show the rope over here like that, and these are the particles of the rope. So if this particle is moving with a speed of 30 kilometers per hour, every particle over here would be moving with a speed of 30 kilometers per hour. कहने का मतलब है, if the truck is moving with 30 kilometers per hour, this point 30 kilometers per hour, 30 kilometers per hour, 30 kilometers per hour, 30 kilometers per hour, and eventually the car would also be moving with a speed of 30 kilometers per hour. Okay, now is a car free to move? No, it is not free to move. Is it acting under the action of some kind of restrictive force? Possibly it is acting under the action of a restricting force, because the motion of the car depends upon the motion of the rope or the motion of the truck. The velocity of the car would depend upon the velocity of the truck, which in effect will transfer the velocity to the rope, and that would transfer the velocity to the car. And the velocity of the car is not something which is independent of these two. It would depend upon these two. So it is definitely moving under the action of restrictive forces. So that is it. So the first method that we employ we are talking about constrained motion, and like I said, we're going to employ two methods to solve numericals. The first method, this is we will initially obviously be discussing method 1, and method 1 is in terms of velocity and its components and the point of contact method. So basically method 1 would be, we will be involving two such methods when we are talking about method 1. So method 1 में एक तो है velocity and its components and the other is the point of contact method. देखेंगे हम लोग क्या कर रहे हैं. Okay, so first question, example 1. Example 1, we have a surface here, we have a pulley there, and we have a block, and this is connected to another block, and this block is on this surface and this angle is 37, all right, and this is block A, that is block B. The velocity of block A is 10 meter per second. Question is what is the velocity of block B? Now let us analyze the situation. तो इधर क्या है? We have to find the velocity of body B. Now as far as the block is concerned, this block is moving with the speed of 10 meter per second and the string is connected to the block. So each and every point of the string is going to be moving with a speed of 10 meter per second. So the string over here moves with the speed of 10 meter per second. Now the velocity of the block, let us say over here is VB. Now would the component of VB over here be VB cos theta? So we have VB cos theta, that is cos of 37, would be equal to how much? Would be equal to 10. Now we know cos of 37 is 4 by 5, so that is 10. So we have VB as 50 by 4, that is 25 by 2, that is 12.5 meter per second. So this is speed of this is 10 meter per second. The speed of this would be 12.5 meter per second. That is example 1. Example 2. See over here, if you see, we are using velocity and its components and solving. And if you have seen, as far as block B is concerned, the motion of block B is not independent of the motion of block A. Block B is moving, or it is constrained, or it is restrictive under the action of restrictive forces. It is moving in a pre-decided path. So this is what we basically mean by saying constrained motion. Okay, example 2 now. Example 2. Example 2, we have something like this. Okay, here we have a ring and this is tied by a string, that is a pulley, and we have a block over here and that is block A and that is ring R. And this angle is 53 degrees and block A is moving in that direction with a speed of 3 meter per second. Question is, what is the velocity of the ring? Now as far if the block is A is moving in that direction with 3 meter per second, this is 3 meter per second, 3 meter per second, so the string over here is moving with a speed of 3 meter per second. Now this is velocity of the ring, so the component over here is going to be what? VR cos 53, and that will be 3, or VR is going to be 3 by 5, that is 3, so VR is going to be 5 meter per second. So that is going to be the speed of the velocity of the ring. That was example number 2. Example number 3. If you see, we are going a little at a faster pace because we will have to attack about 20 to 25 numericals using both the methods to solve them respectively. So here we have a rigid support and there is a pulley, and it is connected to two blocks like that. There's a block here and there's a block there. It is on a surface like that, okay, and this is block A, that is block B, okay. Now this angle is 37, that angle is 53. Block A, VA, is moving with a speed of 3 meters per second. We have to find the velocity of block B. Now if this is moving with a speed of 3 meters per second over here, then it is obvious that the component of the velocity over here is going to be rather in this direction, the velocity would be, say for example, we have A over here, this is A, and A is moving in that direction with 3 meters per second, okay. And if you choose this line, this is 37, so this is going to be 37, so the component over here is going to be 3 cos 37. So the velocity of the string over here is going to be 3 cos 37. So the velocity over here is going to be 3 cos 37, and the string over here is inextensible, so the velocity of the string over here is going to be 3 cos 37. This is the velocity of the block B, so the component of VB over here will be VB cos 53. So we have VB cos 53 is 3 cos 37. So we have V 3 by 5 is 3 4 by 5. So we have VB, of course. So we have VB as 4 meters per second. Okay, so that is example 3. Now I'm going to show you a method. This all comes under the velocity, or using the velocity under its components, and eventually we'll talk about something known as a point of contact method also. There's going to be another method, method 2, using which you can actually solve all these numericals, not using different methods but using one single method. Now let us see, for example, we have a note. Note kya hai? If you have a pulley over here, and a pulley, pulley is fixed over here, and we have a block over here, and the block is A and this is B. Now if A moves down with a speed of 4 meters per second, then B is obviously going to move up with a speed of 4 meters per second. So this is a no-brainer. This is simple. There's no issues because the pulley over here is at rest. So there is no question of any discussion. So if the block moves down with a speed of 4 meters per second, the block B is going to move up with a speed of 4 meters per second. But what if you have a situation like this? This I'll take as example. I'll take it as example 5, although the numbers don't match, but रहने दो इसको, example 5 लेंगे इसको. तो ये है एक formula derive करेंगे. ये है pulley, and the pulley is now moving up with a speed of Vp. Okay, and there is a string which goes around it, and you have a block here and you have a block here. This is block A and that is block B, and that is of course pulley ka level, so center of mass level. Acha. Now the pulley over here, like I said, is moving up, and either A may move up or B may move up, or both A and B may move up. We don't know. Okay, so what exactly are we saying? Let us say that this distance we will take as y1, and that distance we will take as y2. Now would you agree with me that y1 plus y2, let us say, is some y, where y is the length of the string. Okay, now if it is the length of the string, then if I differentiate this, so if I write dy1 by dt plus dy2 by dt is equal to dy by dt. सबसे पहले y is what? The length of the string, and we are talking about an inextensible string, so the variation of the string with respect to time is 0. So this is definitely 0. So we have what? dy1 by dt plus dy2 by dt is equal to 0. Now what exactly is y1? y1 is the distance or the displacement of A from the center of mass of the pulley, and B is the distance from the center of mass of the pulley. Now if the pulley is moving up, this pulley is moving up, and if A, let's say, is moving up, then y1 is changing, and let us say B is moving down, then y2 is also changing. So if y1 changes and y2 changes, then the rate of change of y1 and the rate of change of y2 will give you the velocity of A and the velocity of B. वो तो clear है. So this over here is the velocity of A. Now velocity of A with respect to what? y1 is what? y1 is the distance of A from the center of mass of the pulley. So what is dy1 by dt? It is the velocity of A with respect to the pulley. What is that? Velocity of B with respect to the pulley. Now this is a relative velocity, so we can write VA minus VP plus VB minus VP equal to 0. So from here, is it not very clear that VP is VA plus VB by 2? ये है तुम्हारा shortcut formula. So if you till now we were talking about the pulleys being at rest, but if you have the pulley which is also moving, then on either side the sum of the velocities divided by 2 would be the velocity of the pulley. The sum of the masses on either side divided by 2 would be equal to the velocity of the pulley. इसको अब हम लोग यूज करेंगे प्रॉब्लम सॉल्व करने के लिए. अब तक जो प्रॉब्लम्स कर रहे थे वहां पुली वाज एट रेस्ट. नाउ द पुली इज आल्सो इन मोशन. सो एग्जांपल 5 में एक एग्जांपल सॉल्व करेंगे. सबसे पहले ये रहा पुली, मास, pulley is moving up. This is pulley is moving up with a speed of 4 meter per second, and we have A over here, we have B over here. A is moving down with a speed of 5 meter per second. Question is, what is the velocity of B? Now formula क्या है? Formula तो है VA plus VB by 2 is equal to VP. Now एक बात तुमको clear होना चाहिए कि यहाँ we have a up and down concept. If it is going up and you write this as 4, and if it is going down you write this also as 4, then you're not talking about velocity, you're talking about speed, because then when you're finding out the velocity of something you would not know what would be the direction. Is it going up or is it going down? Correct, no? So if it is going up we will consider that as positive, if it is going down we will consider that as negative. So we have A going down, so VA is negative, so VA की जगह में क्या लिखूँ? -5 प्लस VB को VB लिखो, प्लस माइनस लिखने का जरूरत नहीं है, वो देखेंगे जब आंसर आएगा तब समझ में आएगा. पॉजिटिव हुआ तो इट इज गोइंग अप, नेगेटिव हुआ तो इट इज गोइंग डाउन. सो वी हैव VB by 2 and VP is what? 4. So we have -5 plus VB as 8, so we have VB as 13 meter per second. पॉजिटिव आया मतलब इट इज गोइंग अप with a speed of 13 meter per second. Okay, ये हो गया. Now we'll talk about a very interesting case, और ये interesting case को ध्यान में रखो. कभी कभी न्यूमेरिकल्स जब पूछेंगे तो you don't even have to solve it, एकदम शॉर्टकट में 2 सेकंड में तुमको आंसर आ जाएगा अगर तुमको लॉजिक पता हुआ तो. एग्जाम्पल 6. We have a pulley this is connected to a rigid support, and here we have a block. Block is A. Pulley is going up with a speed of 10 meter per second. Question is, what is the velocity of point A? Now here pulley is moving, so if pulley is moving we can write VA plus VB की जगह में ये support है तो S लिखेंगे by 2 is VP. Velocity of support है, rigid support है तो वो 0 ही होगा, तो it will be this A, VA by 2 is VP is going up, so ये 10 है, so VA is 20 meter per second. तो ये अगर सिचुएशन हुआ तो यहाँ तुम क्या देख रहे हो, यहाँ you are seeing that if you have a support over here, you have a block over here, and if you have the pulley over there, if the pulley is going up with 5, then A will go up with 10. If the A is going up with 10, then the pulley is going up with 5. मतलब पुली का डबल A में होगा, A का हाफ पुली में होगा. वापस सुनो, पुली का डबल A में होगा या A का हाफ पुली का होगा. ओके, एग्जाम्पल 7 करेंगे. Here pulley, pulley is going up with a speed of 2 meter per second. This is A, that is B. A is also going up with a speed of 5 meter per second. We have to find the value of B. तो वापस VA plus VB by 2 is VP. तो VA ऊपर की तरफ जा रहा है तो 5 plus VB by 2 is 2. So we have 5 plus VB is 4. VB is -1 meter per second. That means this guy is actually going down with a speed of 1 meter per second. Okay, that was number 7. I hope you are enjoying the set of numericals, because they are pretty different from what we have actually attacked in the 11th or in the 12th standard. Acha, example number 8. Rigid support, pulley, this is A, and this is B, that is C. Now it is given that A is going down with a speed of 10 meter per second, and B is going up with a speed of 5 meter per second. What is the velocity of C? Okay, now how do we solve it? सबसे पहले let us call this as pulley 1 and this over here as pulley 2. Now if you just see this situation, ये जो situation है, अगर तुम agree करते हो तो ये situation was the kind of numerical that we have just done, 2 numericals ahead. So pulley ka speed is going to be half of this speed. Okay, so that is a shortcut that you remember. So could I write, first of all, VA is what? Minus 10 meter per second, it is going down. So therefore velocity of pulley 1 is going to be half of that, that is minus 5 meter per second. So if pulley is going down with a speed of 5 meter per second, that means this is going to go up. Pulley 2 is going to go up with a speed of 5 meter per second because it is a single string. So therefore we can write VP2 is going to be प्लस 5 मीटर पर सेकेंड, दिस वॉज गोइंग डाउन तो नेगेटिव है, दिस इज गोइंग अप तो वो पॉजिटिव है. सो अभी यहाँ अगर वो अपना पुली वाला फॉर्मूला यूज़ किए तो वी कैन राइट Vp2 इज Vb प्लस Vc बाई 2. Vp2 क्या है, दिस 5. Vb क्या है, इट इज़ गोइंग अप तो वो है 5 प्लस Vc बाई 2. सो वी हैव 10 is 5 plus Vc, so we have Vc as 5 meter per second. So Vc is also going up with a speed of 5 meter per second. Okay, now अब तक जो मेथड हम लोग एम्प्लॉय कर रहे थे वो वेलोसिटी का ले रहे थे या वेलोसिटी एंड इट्स कंपोनेंट्स का ले रहे थे, या वी वर टॉकिंग अबाउट basically talking in terms of velocity only. Now we are going to again we are going to go to a method which is known as the point of contact method. Listen to this very carefully. थोड़ा सा अटपटा लगेगा, initially it may sound a little weird, but if you get a hang of it, no issues whatsoever. So we are now going to talk about the point of contact method. The point of contact method. Let us say we have a block here and there's a pulley, all right, and this pulley is being pulled in that direction. 1 minute. We have a pulley here and so we have a block here that is a pulley, and this pulley is actually wound over here, पूरा wound up है. तो थोड़ा issues है, but doesn't matter. You just understand the logic and that should explain that. Now this is a pulley, that is a pulley, it is fixed to a rigid support. This is not movable, this is a block, this can move. Idea क्या है, you are moving this in that direction with some velocity, and let that velocity be 10 meter per second. So what is the logic is, you will have to first isolate where or what is the point of contact of the string with. String is touching which places, which points are is it in contact. So we have one point of contact here, one, we have second point of contact here, we have third point of contact here, and we have fourth point of contact here. Now let us analyze. Over here, first of all, don't forget that the length of the string is going to be length of the string is going to be a constant. If the length of the string is going to be a constant, that means the rate of change of its length is going to be 0. The rate of change of its length is going to be 0. That means जैसे हम लोग पहले किए थे v1 plus v2 of the y1 and y2, the अलग अलग portion of the length of the string लेके किए थे. यहाँ भी if you consider different portions and if the distance between any 2 points is changing, then there is going to be a velocity, but the eventual length of the string is not changing, so the eventual velocity is going to be 0. So this guy over here, logic क्या है, this is moving in that direction with the speed of 10 meter per second. तो ये जो point of contact है, ये point of contact ये length को बढ़ा रहा है या घटा रहा है, because it is moving in that direction. This point of contact is increasing the length with the speed of what, 10 meter per second. तो तुम इसको क्या, ये इसका speed a है, ये हाँ, तो ये इट इज मूविंग इन दैट डायरेक्शन, वो देखेंगे हम लोग. सो दिस ओवर हियर इज मूविंग इन दैट डायरेक्शन एंड द लेंथ ओवर हियर इज इंक्रीजिंग, सो यू विल टेक दिस एज plus 10 meter per second. Now ये जो point of contact है, this is not changing anything, this is at rest only. ये जो इधर ही है, ये आगे नहीं बढ़ रहा है, पीछे नहीं बढ़ रहा है, ये point इधर बढ़ रहा था, मतलब ये जो point of contact it was moving in that direction, और ये जो length है ये बढ़ रहा था. तो length अगर बढ़ रहा था तो you will take the velocity as positive. ये जो point of contact है, that is that is wherever it is here only. ये आगे बढ़ रहा था. सो ओवर हियर ड्यू टू दैट द वेलोसिटी इज जीरो. ये पॉइंट ऑफ कांटेक्ट के लिए वेलोसिटी जीरो. ये पॉइंट ऑफ कांटेक्ट इज इट मूविंग इन दैट डायरेक्शन, सो द लेंथ ऑफ द स्ट्रिंग इज बिकमिंग व्हाट, द लेंथ ऑफ द स्ट्रिंग इज रिड्यूसिंग. सो यू विल टेक दिस एज नेगेटिव, सो इट विल बी माइनस VA एंड द सम इज गोइंग टू बी इक्वल टू जीरो. व्हाई इज द सम इक्वल टू जीरो? बिकॉज द नेट लेंथ ऑफ द स्ट्रिंग इज अ कांस्टेंट. In between any 2 points the length is changing and the variation of that length with respect to time is the velocity. In between this point and this point the length is changing, the variation of that length with respect to time is velocity, but the eventual length of the string is a constant, so the rate of change of length with respect to time is going to be zero. So this is going to be zero. So from here I think you get VA as 10 meter per second. So this is the logic. This is known as the point of contact method. I think you will understand this in more detail when we actually solve the numericals. So without wasting too much time or without too much ado, let us begin with the numericals. We are talking about example 9. Example 9 mein we have rigid support, block, हाँ, ये है A, ये है B, ये है C. Now A over here, or rather B over here, VB is it is moving down with a speed of 6 meter per second. A is moving up with a speed of 2 meter per second. तो VC का वैल्यू क्या है पूछा है. तो सबसे पहले पॉइंट ऑफ कांटेक्ट क्या है वो आइसोलेट करेंगे. द स्ट्रिंग टचेस दिस इज पॉइंट ऑफ कांटेक्ट नंबर 1, पॉइंट ऑफ कांटेक्ट नंबर 2, पॉइंट ऑफ कांटेक्ट नंबर 3, नंबर 4, नंबर 5, number 6, number 7, number 8. Acha, as far as if this is moving down, you're showing that this is going up. So as far as A is concerned, it is going up. So what is doing it to the length? The length is decreasing. So velocity क्या लेना है? Negative. 2 is neither moving up nor moving down, so it is not changing the length. That point of contact के लिए velocity 0. 3 के लिए velocity 0. 4, if you agree, B is going down, so 4 is going down, the length is increasing. So as 4 is going down, then the velocity that you will consider is positive, so it will be plus 6. 5 is also going down, so plus 6. 6 is neither going down, 7 neither going down nor going up, so plus 0, plus 0. और ये C का पता नहीं, देखते हैं प्लस है माइनस है, तो प्लस C लिखेंगे अगर, and that sum will be equal to 0. ना ये सॉल्व करने पर अगर VC पॉजिटिव आया तो it is going up, अगर VC नेगेटिव आया तो it is going down, as simple as that. So this is what 12 and this is minus 10, so this is going to be 10 plus VC equal to 0, so we will get VC as minus 10 meter per second. That means VC is going down with a speed of 10 meter per second. So that was example number 9. I'm sorry, example number 9 था वो. चलो example number 10. I'm doing so many numericals with you so that you basically or fundamentally get a hang, and it becomes a part of your mindset that yes, or whatever be the kind of question, I have done something similar, so I should be able to do it. So that is the logic, that is the fun day behind why we are doing so many numericals. Question number or example number 10. here we have a block here, and there's another block here. Okay, this is block A, that is block B. Block A is moving in that direction with a speed of 10 meter per second. We have a pulley here, there, and it is connected to a rigid support. यही है ना? अच्छा. So question is, what is the velocity of B? चलो जी, point of contact ढूंढते हैं पहले. ये है एक point of contact 1. This is number 2. This is number 3. This is number 4. This is number 5. And this is number 6. Okay, as far as point number 1 is concerned, it is moving in that direction. Length is increasing. Speed is 10 meter per second. So plus 10 meter per second. As far as 2 is concerned, B is going to move in that direction. The length will decrease, so it will be minus VB. 3, it will move in that direction. That means minus VB. 4, it is moving in that direction, plus 10. 5, moving in that direction, plus 10. This not moving, plus 0, equal to 0. So here we have what? Minus 2 VB is equal to minus 30. So VB is 15 meter per second. समझा? Beautiful method, no? मजा आ रहा है ना? तो ये हो गया example number 10. Example number 11. Example number 11. इसको लेंगे ऐसे. This is A, this is B. A is moving down with a speed of 4 meter per second. Velocity of B क्या है? Okay, point of contact ढूंढते हैं. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if it is going down, 1 is going down, length is increasing, so plus 4. 2, 3 not moving, plus 0, plus 0. 4 going down with the speed of मतलब 4 is going down because this is 4 will be going up, तो ये length घटेगा, तो it will be minus VB. 5 घटेगा, minus VB. 0, 0, plus 0, plus 0. 8 ऊपर जाएगा, माइनस VB. 9 ऊपर जाएगा, माइनस VB. वो तो 0 है, प्लस 0 इक्वल टू 0. सो वी हैव 4 minus 4B equal to 0. VB is equal to 1 meter per second. So basically B goes up with a speed of 1 meter per second. That was example number 11. Now example number 12. Example 12. Pulley, block, and the block is B, and this is A, and A is moving in that direction with a speed of 10 meter per second. Question is, what is the value of the block B? Now we have to be a little careful in this case. Careful क्यों? क्योंकि when you're talking about the velocity of the block B is going to slide like that. So it is sliding like that with respect to the wedge A. So velocity of B का मतलब क्या है? It will move as far as A is concerned in that direction. But A is also moving in that direction, so B will also move in that direction. So this will be giving you the velocity of block B with respect to the wedge. This will be the velocity of the wedge. So what will be the velocity of B? It will be the resultant of these two. तो वो बहुत ध्यान में रखो. क्वेश्चन में क्या पूछा है वो ध्यान में रखो. अगर क्वेश्चन में पूछा है velocity of block B, then you will have to find out the velocity of B with respect to the wedge, जो अभी हम लोग find out करेंगे. It is anyway moving in that direction with 10 meter per second, so that resultant will actually give you the velocity of block B. Now chances are they may mix up the question, this may not be in the answer, that means the expected answer is that. So when you are asked a question like this, not only will you find this, you will also find that, because in the option this may also be there and this may also be there. Now if this is also there, this is also there, this is the answer. If this is there, this is not there, then that is the answer. दिखाता हूँ मैं. तो इधर पॉइंट ऑफ कॉन्टैक्ट आइसोलेट करेंगे हम लोग. सो व्हाट इज द पॉइंट ऑफ कॉन्टैक्ट? नंबर 1, नंबर 2, नंबर 3. 1 is concerned not moving anywhere, to 0. 2, the wedge is moving in that direction, length घट रहा है, -10. As far as 3 is concerned, when the block is moving here, the B will slide down, so this length is increasing, so it will be plus VB equal to 0. So VB nahi, VB with respect to the wedge. So therefore VB with respect to the wedge is 10 meter per second. So this is actually VB with respect to the wedge. Now you know what is the VB with respect to the wedge. VB with respect to the wedge is 10 meter per second. The wedge velocity, V wedge, is 10 meter per second. So the velocity of B is actually the resultant. So that is VB. So we have VB vector as VBW vector plus VW vector. So VB is going to be under root of VBW squared plus VW squared, that is root of 10 squared plus 10 squared, that is 10 root 2 meter per second. So in your answer, if you have a 10 meter per second given and a 10 root 2 meter per second, then 10 root 2 meter per second is your answer. In the answer, if you have a 10 meter per second and no 10 root 2 meter per second, then you are expected to take 10 meter per second as the answer. That brings us to the last question, not of today's video, but of the method 1. इसके बाद we will talk about a method which is my choice. I like that method. Like I said, when I was a kid like you, when I was preparing, I normally solved questions, numerical, these kind of numericals, using the method which I'm going to teach you right after this numerical. And that is example number 13. Example 13. We have an inclined plane, pulley, 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 this is wedge A, that is block B. Wedge A is moving in that direction with 10 meter per second. Question is velocity of block B with respect to the wedge is how much? चलो पॉइंट ऑफ कांटेक्ट ढूंढते हैं हम लोग. 1 नंबर, 2 नंबर, 3 नंबर, 4, 5, 6. अच्छा ये तो भूल ही गया हम लोग. चल इसको 7 पकड़ता हूँ. 7 से चालू करते हैं हम लोग. 7 से this is going down, so if it is going down, the length is increasing, so it will be plus VBW. Wedge is moving in that direction, so the length over here is decreasing, so minus 10. Rest, plus 0, rest, plus 0, moving in that direction, minus 10 equal to 0. So we will have what? We will have VBW as 20 meter per second. And of course अगर तुमको VB फाइंड आउट करना है तो ये होगा तुम्हारा 10 मीटर पर सेकेंड, ये होगा 20 meter per second. Find the resultant, that will be the velocity of the block. The velocity of the block is going to be under root of 10 squared plus 20 squared, root 500 ka squared, that is 10 root 5. So that is your answer. That is as far as so ye VB is 10 root 5 meter per second. Abhi we will begin with method 2. मेथड 1 में जो न्यूमेरिकल्स किए थे, काफ़ी हद तक the number of numericals that we are going to do are going to be repetitions, because we are going to it is basically a video of comparison for you to make a choice, because I am giving you the freedom to make a choice. I am not telling you that this is what you are expected to do only. Choice is yours. Whatever you are comfortable with, whatever helps you enhance your speed while solving the numericals, that is going to be your choice. Okay, so method 2 is work done due to tension. Work done due to tension. सबसे पहले we have studied that or we know that in physics, when you talk about work, in physics when you fundamentally or basically talk about work, you are only talking about work done due to an external force. Tension acting on a string is not an external force. Tension acting on a string is an internal force. And work done, external work done due to an internal force is 0. Example मैं काफ़ी बार दे चुका हूँ, मेरा favorite example है, if you are sitting on inside a car, you're sitting on the rear seat of a car and you push the front seat of the car. When you push the front seat of the car, can you move the car? The answer is no. Why can you not move the car? Because you are exerting an internal force, and due to that internal force, the acceleration of the car is going to be 0. Internal forces cannot produce an acceleration. So work or external work done by internal force is 0. So first of all, tension is an internal force. Internal forces cannot produce acceleration. External work done due to internal force is 0. So if you have a situation का मतलब है, you have a pulley over here and there's a load over here, and the string goes over here, and although this may not be entirely true, but just for the heck of our understanding I'm showing it to you, just for the heck of our understanding, ये M1 है, ये M2 है, तो यहाँ टेंशन T1 है, यहाँ टेंशन T2 है. तो due to the tension over here, मान लो over here there is some displacement x1, and over here there is some displacement x2. So what is the work done ka formula? Work done is F dot displacement. So over here, what is the work done formula? It will be T1 vector dot x1. This is the work done due to T1. And what is the work done due to tension T2? It will be T2 dot x2. और हम लोग क्या देख रहे हैं कि the external work done due to internal force is 0. That means the sum of these two works is equal to 0. So therefore in general इसको कैसे लिखेंगे हम लोग? In general we can write this as summation T dot x equal to 0. T dot x is equal to 0. Summation of tension dot displacement is 0. Differentiate अगर करेंगे इसको, so we will get T1 dot dx1 by dt is velocity 1 plus T2 dot velocity 2 is equal to 0. So in general कैसे लिखेंगे? Summation T dot v equal to 0. इसको डिफरेंशिएट करेंगे तो क्या मिलेगा? T डॉट A1 प्लस T1 है या T2 डॉट A2 equal to 0, and in general we will have summation T dot A equal to 0. These are the formulae that we are going to use to solve the numericals that we are going to do now. In the previous method, I am going to repeat this. In the previous method, we had used the concept of velocity, the concept of component of velocity, a new concept that we studied which was known as a point of contact method. All those numericals can be easily solved by using this idea. The idea is what? That the summation of tension dot acceleration is 0, tension dot velocity is 0, tension dot displacement is 0, and this all comes from this basic structure of physics. And if you feel that ये बहुत heavy हो रहा है, you can simply use this. ये भी बहुत heavy हो रहा है, previous method तो बताया हूँ तुमको, तो जो तुम्हारा choice है वो तुम employ करो. चलो, without wasting too much time, let us begin with numericals over here. एग्जाम्पल कहाँ तक किए थे? वहाँ 13. तो एग्जाम्पल 14 अभी. एग्जाम्पल 14 में we have pulley, अच्छा, इसका मास है 5 kg एंड इसका है 2 kg. एक मिनट, क्या गलत कर रहा हूँ? दिस इज 2 kg एंड हाँ, this is accelerating in the downward direction. So ये है तुम्हारा A2 and this is A1. Question is find the value of A1 कितना है, A2 कितना है, वो तुमको find out करना है. सबसे पहले if this is concerned, over here we are going to have a force which is mg, that is 5g, and over here you are going to have a force which is mg, which is 2g. ये तो clear है. यहाँ tension है T and the string is the same, so the tension would be the same. यहाँ T, यहाँ T. Now we have studied what? We have studied that summation of T dot A is equal to 0. T dot A का मतलब है TA cos theta, TA cos theta. तो वो वाला यहाँ अप्लाई करेंगे सबसे पहले. तो यहाँ T ऊपर है, acceleration is in the downward direction, acceleration is what? A2. So angle is 180, cos 180 is -1. So we will write what? Minus TA2. Let us come here. We have T here, T here. So total tension is what? 2T. And over here, what is the acceleration to be taken? A1. A1 is what? In the same direction as tension. So cos of 0 is 1. So we will have plus 2T A1 equal to 0. So from here, we will get A2 as twice A1. So if we make a statement, let A1 be A. So we will have A2 as 2A. Now using the concept of the free body diagram का मतलब क्या? 5 kg, ये है 5 kg, ये है tension, this over here is 5g, and this is accelerating in the downward direction with A2 क्या लिया हम लोग? 2A. So using the free body diagram, could we write 5g minus t is equal to, ये इसका acceleration है, mass 5 kg है, so 5 into 2a, so it will be 5 into 2a, that is 5g minus t is 10a. And for the second mass we have 2 kg mass, that is tension, that is 2g. It is going in the upward direction with A1 we have taken as A. So over here we will write what? For this we will write T minus 2g is 2a. Okay, we have to solve these two equations. So these two equations के लिए ये 2t है ना, t भी है, मतलब this is also there, this is also there, so it is 2t, so it is 2t. Now we would like to solve this, so we multiply this by 2, so we get 10g minus 2t is equal to 20a, or we add this to this. So when we add this to this, 2 and 2 get cancelled, we'll get 10g minus 2g as 20a plus 2a, so we get 8g as 22a. A is equal to 8g by 22. So acceleration क्या आया? A1 is equal to A, so A1 is equal to A is equal to 8g by 22, and A2 is twice A, that is 2 into 8g by 22, that is 8g by 11 meter per second squared, itna meter per second squared. Now in the previous methods there was no mention about acceleration. तो acceleration के लिए तो तुमको यही method employ करना पड़ेगा. Previous methods you could only solve for velocity, but if you are talking about acceleration, this happens to be the only method that you can employ. Of course you can use this to work for velocity also, work for displacement also, but there it was only for velocity. Acceleration के you would have to actually differentiate that and get the answer. चलो example 14 हो गया. Example 15. Example 15, we have this is 5 kg, this is going down, acceleration is A1, this is 2 kg, acceleration is A2. Question is A1 find out करो, A2 find out करो. सबसे पहले टेंशन है इधर T, इधर T, इधर T. Important thing is summation T dot A equal to 0. टेंशन ऊपर, एक्सेलरेशन नीचे. एक सिंपल बात कर लेंगे पहले. वी विल मेक अ स्टेटमेंट, लेट A2 बी इक्वल टू A. हाँ, वो ध्यान में रखो सिर्फ. करेक्ट. तो T डॉट A, सो T ऊपर, एक्सेलरेशन नीचे, तो क्या करूँ? माइनस होगा ना, बिकॉज दिस विल बी T A1 cos थीटा, थीटा इज 180. सो वी हैव माइनस T A1, इधर T भी है, इधर T है, सो 2T, एक्सेलरेशन इज इन द सेम डायरेक्शन, सो प्लस 2T A2 इक्वल टू 0. सो देयरफॉर वी हैव A1 as 2A2. So from here our conclusion is what? That we have shown that A2 is A, so therefore A1 is 2A. Free body diagram here. T is there up, accelerating down, mg will be down, so we can write for this, we will write 5g minus t is 5, A1 क्या है 2A, so we will get 5g minus t is equal to 10A. अच्छा, इधर क्या है 2t और एक्सेलरेशन उधर ही है, so no issues only, so we have 2t will be equal to 2 into acceleration a to a, so we have t as equal to a. So using this there, we can write 5g minus a equals 10a, so we have 5g is equal to 11a, so we have a as 5g by 11, so क्या क्या find out किया, a2 is equal to a as 5g by 11 and a1 is 2 into a, 2a, that is 2 into 5g by 11, that is 10g by 11, of course meter per second squared, meter per second squared. So that is question number 15. देखो अभी काफ़ी सारे सम्स जो हम लोग पहले किए थे उसको रिपीट करेंगे और देखो क्या क्या फाइंड आउट करते हैं हम लोग, आपको क्या लगता है इजी वो आप देखो. क्वेश्चन नंबर 15 था ये, क्वेश्चन नंबर 16, एग्जाम्पल 16 में we have a block, we have another block, okay, थोड़ा सा डिफरेंट करेंगे मगर लॉजिक तो सेम ही रहेगा. ओके, ये है A is moving, it has got an acceleration over here of 5 meter per second squared. ये B है, तो B का acceleration क्या है वो तुमको AB, और ये है AA. AA is 5 meter per second squared. Okay, चलेगा. Okay, now as far as A is concerned, क्या क्या लॉजिक है. A के लिए टेंशन इधर है, A के लिए टेंशन इधर है, दिस इज इन कॉन्टैक्ट. B के लिए टेंशन इधर है और इधर है. तो समेशन T डॉट A इक्वल टू 0. देखो यहाँ एक्सेलरेशन से कर रहे हो, अगर वेलोसिटी had there been a mention of velocity, then you would have simply taken T dot V equal to 0 and you have to solve for velocity. Here we are solving for acceleration. In other words, you will solve for velocity. In the previous sum that we had done using the previous method, we were finding out velocity. So you can do that here also. Only thing is you will take T dot V is equal to 0, because I think we have seen summation of T dot A equals 0, summation of T dot V equals 0 and summation of T dot X equals 0. So it is all encompassing. You can find out anything and everything that you want. So in this case we have, as far as A is concerned, you have this is tension. As far as A is concerned, T है, so 2T है, acceleration उधर है तो माइनस होगा, so it will be minus 2T into A, which is acceleration क्या है 5. B के लिए T है, so it will be plus 3T, acceleration in the same direction, so AB equal to 0. So we have 10T equals 3T AB. So we have AB as 10 by 3 meter per second square. ठीक है, ये है 16. 17 would be an exact same sum. तो अभी देखो तुम 17 वेलोसिटी के साथ ही करेंगे इसको. एग्जाम्पल 17, Okay, we have B over here. This is, let us say, 37 degrees, and this is A. A is moving over here with a speed of 10 meter per second. Question is, find the velocity of B. Okay, as far as A is concerned, you're going to have tension here. As far as B is concerned, you're going to have tension there. So we, I think, know this is VB, so VB idhar hai, this is VB. So component of velocity here is going to be what, VB cos theta. But लेने का भी ज़रूरत नहीं है, I'll show it to you why. So we know we have T summation T vector dot V vector equal to 0. So यहाँ we will apply T इधर है, velocity उधर है, opposite direction है, so minus. So T into 10 plus ये क्या है T, ये क्या है VB, angle क्या है 37. So we have dot product है ना, so it will be T V cos VB, sorry, cos 37 equal to 0. So we have T10 equals T VB, cos of 37 is what, 4 by 5. So we have VB as 50 by 4, 25 by 2, 12.5 meter per second. Yaad karo. I think it was some number 3 or 4 in the previous method. We had got a similar, exact same answer. Method was different. ये था question number 17. Question number 18. Example 18 में we have that is A, that is B, this is fixed over here. Okay, and acceleration of B is given as 10 meter per second squared. Acceleration of A कितना है वो find out कर रहे हो. Obviously A is going to move in the upward direction only, so that is acceleration of A. ये tension T, ये T, ये T, ये T, ये T. So as far as this is T, 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 we have summation T dot A equal to 0. तो इसके लिए करेंगे T इधर, acceleration उधर, negative sign, so minus T into 10. A के लिए 1, 2, 3, 4. So we have plus 4T, acceleration in the same direction AA equal to 0. So we have AA as 10 by 4 meter per second square. ये हो गया 18. Okay, 18 done. 19. Example 19. We have a rod here, we have a ring here, pulley, load. This is the ring, and this angle is 53 degrees, and A is moving down with a speed of 5 meters per second. What is the velocity of the ring? That is what you are finding out. चलो जी, टेंशन T. तो इसके लिए टेंशन ऊपर, वेलोसिटी नीचे, समेशन t vector dot v vector is 0, तो ये माइनस होगा, so it will be minus t into 5, and this is t, velocity r, angle 53. So we have t v of the ring cos 53. So we have t 5 equals t vr 3 by 5. So we have vr as 25 by 3 meter per second. Okay, that was 19. Example 20. We have a pulley here attached to a load M. This angle is theta. This is pulled down with a velocity u. This is pulled down with the velocity v. This goes up with the velocity v. Question is, what is the velocity of v in terms of u? So that is the question. ये क्या है? ये टेंशन, 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 समेशन t डॉट v इक्वल टू 0. इसके लिए t ऊपर v नीचे, सो वी हैव माइनस t इंटू यू. उसके लिए t ऊपर नीचे, माइनस t इंटू यू. ये t इधर, v उधर, एंगल थीटा. सो वी हैव प्लस t v cos थीटा प्लस t v cos थीटा इक्वल टू 0. सो वी हैव 2tu equals 2tv cos theta. So basically v is equal to u by cos theta. That was example 20. Sorry, example number 20. Now example number 21. Example 21. Example 21 में similar sum like before. Block, block. This angle is 37. That is 53. Block is moving. This is A. 9 meter per second, that is B. VB is how much? Okay, let's solve. That is tension, that is tension. Okay, so this is tension, this is VB, no? This is VA, sorry, which is 9. This angle is what? 180 minus 37. So the angle between VA and T is 180 minus 37. So we have T into, first of all, बेसिक फार्मूला क्या है? समेशन टी डॉट वी इक्वल टू 0. सो टी वी ए कॉस 180 माइनस 37 प्लस टी वी बी कॉस 53 इक्वल टू 0. कॉस 180 माइनस 37 and minus cos 37. So minus टी वी ए cos 37 is टी वी बी cos 53. T and T cancels, VA is 9, this is 4 by 5, that is VB 3 by 5. So we have 3, okay, so VB is 12 meter per second. So that is question number 21. One second. Question number 22 I have pre-drawn. ये है system. This is A, that is B. A is moving down with a speed of 14 meter per second. Question is VB कितना होगा? चलो जी. So सबसे पहले ये है tension T. So this is all T. अच्छा, so summation t डॉट v इक्वल टू 0, इसके लिए v नीचे t ऊपर, सो माइनस t इंटू 14. b के लिए 1 2 3 4 5 6 7, सो प्लस 7t, v ऊपर ही है ना तो प्लस ही होगा, सो vb equal to 0. I think on solving it you will get vb as 2 meter per second. दो स्टेप में आंसर आ सकता है इसका. When you solve it you will get the answer in 2 steps each. So no, not a big deal absolutely if you know this method. यही अगर point of contact method से करते तो ये हर point लेते it would have been 5 or 6 steps, which at least I did not ever like. So it is upon you, whichever you like, you do it. That brings us to the last sum of today's session. Question example 23. ये रहा. This is a wall. That is a stick, bamboo stick, let us say. That is point A, that is point B. This is sliding like that. VA is sliding with a speed of 3 meter per second. So VB is का value क्या है? This angle is 37 and this is 53. तो आइडिया क्या है? यहाँ टेंशन के साथ काम नहीं करेंगे. Here we will talk in terms of reaction. So the stick is pushing the ground like that, so you have reaction like this, and the stick is pushing that and you have reaction like that. Let that reaction be R. So the angle between reaction and velocity over here is what? 180 minus 37. So again summation reaction dot V equal to 0. तो इधर क्या होगा? It will be R VA cos 180 minus 37 plus reaction, और ये है velocity, so we have reaction VB cos 53 equal to 0. So R and R cancels. VA is given as 3 and this is minus cos, so it will be cos 37 and that will be VB cos 53. So this will be minus plus हो जाएगा, so into 4 by 5 and this will be V into 3 by 5. So we have answer VB as 4 meter per second. Okay, so beta, we have done like I said about 23 numericals, and I hope you've enjoyed this. I hope you've understood the logic. I've gone a little fast, like I've said before. There is no option when you're solving so many numericals. You will have to go a little fast. That's when it becomes crisp and you understand it better. So with that we finish off with our numericals of constrained motion. Let's hope that we don't have to do any more new types, till your exams. I think I've covered everything with this session. Okay, have a nice day. Bye bye.